So this is the question of GATE 2014, question number 7 in physics. So it states that the electric field of a uniform plane wave propagating in a dielectric non-conducting medium is given by this particular expression, that is E is equal to 10 x cap cos 6 pi into 10 to the power 7 t minus 0.4 pi z, and of course the unit of the electric field is in volts per meter. Now the phase velocity of the wave is to be found out, and it is given as into 10 to the power 8 meter per second. So we can see that it's a numerical answer type question. Now to understand that, see this electric field, which is a kind of a wave like solution, is being given here. So we need to understand what is the phase velocity, how we can find out the phase velocity, and in that phase velocity expression we have to put certain values and find out what will be the phase velocity if this kind of wave is given. So for that, the step-by-step solution will be as follows. Just a minute. So this one is the step-by-step solution for that. So the electric field of the field wave, I would say, it is given as E is equal to 10 x cap, which is nothing but that E naught vector, and it's the cosine term, the argument of the phase. So cos 6 pi into 10 to the power 7 t minus 0.4 pi z volts per meter. So this is given in the question. So what we need to find out is the phase velocity of this particular wave. Now we know that from the wave equation of the electromagnetic wave, which can be either in terms of electric field E or in terms of the magnetic field B, anything. So it can be written as, the solution of this wave equation can be written as E is equal to E naught cos of omega t minus kx. It can be written as kx minus omega t as well. Only thing is that there will be a phase difference of pi. Now in this particular expression we have written it as cos omega t minus kx. Now from this A, what are these terms represent? E naught is the constant amplitude vector, omega is the angular frequency of the wave, k is actually the wave propagation vector, and x is the direction of the propagation, like x is equal to xi plus yj plus zk. And k can be further component wise, it can be written as kxi cap plus kyj cap plus kz k cap, which are the nothing but the components in the wave propagation direction. Now comparing this particular equation A along with whatever which is given to us, we can therefore write that E naught will be equal to 10x cap. Why? Because this is E naught and this is 10x cap. So this is the constant amplitude vector. So E is equal to 10x cap. Omega is 6 pi into 10 to the power 7 radians per second. The omega's general, what you call as the SI unit is that. So omega is that. And kz is 0.4 pi. Why kz? Why kz? Because this is kxx plus kyy plus kzz. It is only given in terms of z. So comparing, we will get only the kz part. So that becomes 0.4 pi. Now phase of the wave, suppose we consider now only 1D, which is the case here, where we are not being provided about the kxx and kyy is 0. So this is not provided. So for that, what we do is that, so what we do is that E is equal to E naught cos omega t minus kz. We directly write. Now, what is a phase velocity? We need to understand. Phase velocity is that, suppose this is a wave. So phase velocity is that one particular phase I take, with what speed this particular phase is moving. So I have to consider one particular phase. So that becomes theta is equal to constant, where theta is the phase. Okay, so this is the phase. One of the phases I take, that phase theta is equal to constant, and I will see how it is moving with time. That's all. That is the phase velocity. Therefore, theta is equal to, this argument is nothing but the phase of the wave. So therefore, theta is equal to omega t minus kz. Differentiate with respect to time. So we d theta by dt is equal to omega minus k dz dt. We can see from here that dz dt is nothing but a kind of a velocity, right? On the other hand, why we are doing d theta dt? Because I need one constant phase. Therefore, d theta dt, I will put it as 0. So I put d theta dt as 0 because the phase velocity, it is the velocity of any constant phase. Therefore, d theta dt, if I put it equal to 0, we get dz dt is actually, this gives dz dt is actually equal to omega by k. And this dz dt is nothing but the phase velocity, omega by k. So this is the phase velocity expression. And just put Cp now, omega is given, what we have seen is 6 pi into 10 to the power 7, and the kz is also given, that is 0.4 pi. If I do it, 60 by 4 into 10 to the power 7, I take 1 0 into this 10 to the power power term, so becomes 6 by 4 into 10 to the power 8. Why am I doing it? Because in the question it is dash into 10 to the power 8 meter per second needs to be found out, so it becomes 1.5 into 10 to the power 8 meter per second. Therefore the answer is 1.5 in the numerical type question. So let's see this particular question again. So this E is equal to this, for this particular wave the phase velocity of the wave comes out to be 1.5. So let me write it. So it will be 1.5. This is the answer. Thank you.